You can deal with this by labeling each copy of the handout in turn with the initials of each of those present. As long as you do not run out of copies before completing this process, you will know that you have a sufficient number to go around. You have then solved this problem without resorting to arithmetic and without explicit counting. There are numbers at work for us here all the same, and they allow precise comparison of one collection with another, even though the members that make up the collections could have entirely different characters, as is the case here, where one set is a collection of people, while the other consists of pieces of paper. What numbers allow us to do is to compare the relative size of one set with another. In the previous scenario, you need not bother to count how many people were present, as you did not have to know. Your problem was to determine whether or not the number of copies of the agenda was at least as great as the number of people, and the value of these numbers was not required. You will, however, need to take account of the number present when you order lunch for 15, and certainly, when it comes to totting up the bill for that meal, someone will make use of arithmetic to work out the exact cost, even if the sums are all done on a calculator. Our modern number system allows us to express numbers in an efficient and uniform manner, which makes it easy to compare one number with another and to perform the arithmetical operations that arise through counting. In the day-to-day world, we employ base 10 for all our arithmetic. That is to say, we count by tens, and we do that for the accidental reason that we have 10 digits on our hands. What makes our number system so effective, however, is not our particular choice of base, but rather the use of positional value in number representation, where the value of a numeral depends on its place in the number string. For example, 1984 is short for 4 ones plus 8 lots of 10 plus 9 hundreds plus 1000. It is important to understand what we mean when we write numbers in particular ways. In this chapter, we will think about what numbers represent, discover different approaches to counting, meet a very important set of numbers, the primes, and introduce some simple number tricks for finding them. How counting was sorted out. It is worth taking a few moments to appreciate that there are two distinct stages to the process of building a counting system based on, for instance, tens. Two basic tasks that we impose on children are remembering how to recite the alphabet and learning how to count. These processes are superficially similar, but yet have fundamental differences. Our language is based on a 26-letter alphabet, and roughly speaking, each letter corresponds to a sound that we use to speak words. In any case, it is certainly true that the English language has developed so that it can be written using a set of 26 symbols. However, we cannot compile dictionaries unless we assign an order to our alphabet. There is no particularly natural order available, and the one that we have settled on and all sing in school, A, B, C, D, seems very arbitrary indeed. To be sure, the more frequently used letters generally occur in the first half of the alphabet, but this is only a rough guide rather than a rule, with the common letters S and T, for example, sounding off late in the roll call. By contrast, the counting numbers, or natural numbers as they are called, 1, 2, 3, come to us in that order. For example, the symbol 3 is meant to stand for the number that follows 2, and so has to be listed as its successor. We can, up to a point, make up a fresh name for each successive number. Sooner or later, however, we have to give up and start grouping numbers in batches in order to handle the unending sequence. Grouping by tens represented the first stage of developing a sound number system, and this approach has been near universal throughout history and across the globe. There was, however, much variation in detail. The Roman system favours gathering by fives as much as tens, with special symbols V and L for 5 and for 50 respectively. The ancient Greek system was squarely based on grouping by tens. They would use specific letters to stand for numbers, sometimes dashed to tell the reader that the symbol should be read as a number rather than as a letter in some ordinary word. For example, pi stood for 80 and gamma for 3, so they might write pi gamma to denote 83.